In this video, we're going to look at margin of error and sample size. Complete the table below by computing the margin of error for each of the given sample sizes. Round your percent to 2 decimal places. Use a conservative estimate for the margin of error using a 95% confidence interval, where the margin of error equals 1 over the square root of n, and n is the sample size. Also note with this formula, we'll need to change it to a percent because this will give us the decimal value. So written as a percent, and we will round after we change it to a percent. So let's look at the first one. We have a sample size of 100. So the margin of error is 1 over the square root of 100. And then we'll multiply by 100% to change it to a decimal. Notice the square root of 100 is 10, so this is 1/10, which is 10%. But we are going to practice using the calculator. If you have a scientific calculator, you can punch this in directly, but on this calculator, first you need to punch in the 100 and take the square root. There's the 10. We want the 10 in the denominator, so we're going to hit this button to reciprocate it, and then we'll multiply by 100 to change it to a percent. So we have 10%. So a sample size of 100 has a margin of error of 10%. If we have a sample size of 200, using the same formula, we will start with 200, take the square root, reciprocate it, and multiply by 100. And our result is 7.07%. Next, we have a sample size of 400. So 1 over the square root of 400. 400 is a perfect square, so we're going to get a nice answer, or a whole number answer. 400, the square root is 20. Reciprocating this, we get 0.05, and multiplying by 100, we get 5%. And finally, looking at a sample size of 800, we use the same formula. Take 800, find its square root, reciprocate, and multiply by 100. And our result of 2 decimal places, we round up to 3.54%. In addition to getting some practice on computing margin of errors, we also want to look at relationships between sample size and margin of error. So the next question asks us, as the sample size increases the margin of error, and we're going to state whether it increases, decreases, or remains constant. So notice here the sample size is increasing as we move from the top to the bottom, 100, 200, 400, 800. The margin of error is going from 10 to 7 to 5 to 3.54, so it is decreasing. So the larger the sample, the smaller the margin of error. Then we're asked, does doubling the sample size split the margin of error in half? Well, let's take a look. So from 100 to 200, 200 is double 100. The sample size goes from 10 to 7.07, and 7.07 is not half of 10. Okay, and just finding that one example, we could say it's a counterexample, and the answer is no. But let's just look at this for another second. This is a decrease of about 3% from 10 to 7.07. When we go from 7 to 5, that goes down by about 2%. And from 5% to 3.54 goes down by about 1.5%. Okay, those are all approximate. Okay, and in each case we had the sample size doubling. Okay, notice 5% is half of 10%. We had to have a sample size that was 4 times as large to get that result. Okay, so we know that the larger the sample size, the better our precision, the smaller the margin of error. But it doesn't appear that doubling the sample size isn't going to split our margin of error in half. It's going to make it smaller, but at a decreasing rate.